Welcome everybody to another edition of No Hair No Problem. Jeez, sorry, I'm losing my mind here. Um, Rosenwald here with a video for the chapter 8 notes dealing with word problems. We're just going to kind of work through a bunch of different problems here for systems where we're dealing with word problems and like how to basically set them up. Once the problems are set up in these systems, the goal is then to try to solve them and use whatever methods we have available to us. So the two methods that we really are going to kind of lean into are either substitution or elimination. The reality is that solving these is totally your preference. There's no right or wrong way to solve them. There's ways that are just easier than others, but there's really technically no right or wrong way. So anyways, let's go ahead and get started on these, and I'm going to kind of talk you through the setup as much as I can. Let's get me out of the way here, and let's get moving. So first, if you're solving for multiple unknown values, basically what you're going to do is you're going to set up a system of equations, and in addition, we're going to go ahead and have to assign what those unknown values are. So we're going to have to create some variables for those unknowns. So if we take a look at the first example here, it says that we're dealing with the admission fee at a small fair is $1.50 for children, $4 for adults, and on a certain day, 2,200 people enter the fair and $5,500 is collected. So the question here is, well, how many children and how many adults attended if we know this information? So when we look at this, we're talking about the total cost and total quantity that's taken place. And we should realize that we're going to see this in several of the problems that there's two different things generally taking place here. In this one, the first equation we have to talk about is the quantity. Now, quantity is how many people are there. In this case, when we mention this, we say that there are 2,200 people that attended, yet we know that some of those people were children and some of those people were adults. Okay, so let's assign some unknowns. I'm going to go ahead and use the letters C and A to represent children and adults. Now, here's what we know. From the children and the adults, there could have been 10 children and there could have been 2,190 adults. We don't know what the number is. But what we know is that the total number of children and adults combined add up to 2,200. So the children and the adults together, there's going to be a total of 2,200 here. So that's our equation when we're talking about the quantity. We're just talking about how many, right? Our second equation when we're talking about these is going to deal with the cost that's actually taking place. So the cost is the money that's involved. And if we look at here, we're talking about it's $1.50 for every child and then $4 for every adult. So if we look at the adults right here, and I say it's $4 for every adult, if I have one adult, it's just $4. If I have 5 adults, it's going to be 4 times 5. If I have 10 adults, it's going to be 4 times 10. So what we're doing is we're taking each one of these number of people that there are, and we're going to multiply it by how much it costs for them. So for the children, it's $1.50 for every child. And then for the adults, it's at $4 for every adult. And what we know is that the total amount that's collected was $5,050. So we're going to add these together, and that's going to give us our total amount, which is $5,050. So you can see here we've got two equations. Now the method that I chose for this, just to kind of work through it, was I said, let's go ahead and use substitution. So if we use substitution, let's go ahead and set up our t-chart here with both of the equations that we just had. And in order to use substitution, we have to try to get a variable by itself. So we have a couple options. We can get C by itself, we can get A by itself, we can get C by itself, or we can get A by itself. When you're using the substitution method, the idea is to try to get a variable by itself as quickly and as easily as possible. In this case, I chose to get A by itself. Now you could do C, it would still work out the same, but I just chose A. So if I move the C over here, we end up with 2,200 minus C in this problem. Once we know what A is equal to, we're going to take it and substitute it in for the A that's right here. And if we do that, we end up with 1.5C plus 4 times 2,200 minus C is equal to 5,050. Now we just work through and solve like we would any other equation. We're going to distribute first. We will then combine the like terms. We will then divide, because the inverse of multiplying by negative 2.5 is to divide by negative 2.5, and we get that C is equal to 1,500. So this tells us that during that given day, there were 1,500 children that went to this place. Now, we could take that and go back over here. Now that we know what C is, we can go back over here and plug it in for this C right here. And if we do that, we know that A is going to equal 2,200 minus 1,500, So we know that there are a total of 700 adults that went to this. So there you go. At that fair on that day, there were 700 adults and there were 1,500 children. And if we check it, 700 plus 1,500 does in fact equal 2,200. And if we took and multiplied 1.5 times 700, not times 1,500, 1.5 times 1,500, and we add 4 times 700 to it, you'll see that we end up with that 5,050. That's right there. Okay? So this is what we're kind of working towards with each of these problems. So we're going to gradually kind of pick up the pace so we can kind of get through each one of these, okay? Kasha bought 5 bags of Skittles, 3 packages of Oreos, and she paid $34.25. Matt bought 3 bags of Skittles and 2 packages of Oreos, and his total was $28.25. So the question is asking, what's the price of each Skittle and package of Oreos? Well, the two unknowns in this problem are first, Skittles. You could choose an X and a Y. You could choose whatever variable you want. I went ahead and chose K, just because I don't like using an S, because an S tends to look too much like a 5. Okay? And then for Oreos, for obvious reasons, I didn't choose an O because it looks like a 0. So what we said was, look, Kasha bought 5 bags of Skittles and 3 packages of Oreos and paid $34.25. So the equation for this is that it's $5 for each bag of Skittles. It's $3 for each bag of Oreos. And we know that the total going on here is that there's $34.25 being spent. Okay. For the second equation, we have Matt, who bought 3 packages of Skittles and 4, I said $5 earlier and $3. I meant 5 packages. So he bought 3 packages of Skittles, 4 packages of Oreos, and if we take and we add those together, he spent a total of $28.25. So the goal here is to figure out how much are the Skittles and how much are the Oreos. So in this case, I went ahead and used the elimination method. I chose this because when you look at my options, this K is not really by itself yet, nor is this R or this R and this K. If none of my variables are by themselves, it's usually the best method to use then is elimination. Now there's a surefire way to do this, okay? You just pick a letter, doesn't matter which letter. In this case, I say, let's go ahead and get rid of R. So in order to get rid of the R using the elimination method, I use whatever the number is that's right here. I use the exact same number up here. Whatever number I see right here, I use the exact same number down here. The only thing that you then have to do is I use an opposite sign for one of them, just for one of them, just so that the signs end up being opposite each other. Okay, and look what happens when we multiply this out. When I distributed out that negative, everything afterwards became a negative as well. And so you can see right here, we have a positive 12R and we have a negative 12R. So now if I just work straight down here and combine my like terms, these will combine, all 3 of these will go ahead and combine together here. We're left with negative 11K, the 12R is canceled, and we're left with negative 52.75. If we then divide by negative 11, we get K is equal to 4.75. Now that we know what K is equal to, you can plug it into whichever equation you want, literally whichever equation you want. I'm going to go ahead and take my K and I'm going to plug it in over here into these. And I'm going to do it actually in the first one right there. That means we have 5 times 4.75 plus 3R. We then can solve for R. Going through this, just multiply it, move the 23.75, and then we'll divide by 3, and we get that R is 350. So what this means is that when we solve, we found that K is $4.75 for each Skittle and $3.50 for each Oreo, which looks like Oreo for some reason. All right, let me fix that real quick because I don't like the way that looks. That's an Oreo, not Oreo. All right. All right, here we go. So let's move on to our next one here. These are age problems. There's going to be 2 types of age problems we're going to run into here. So let's kind of talk through these. First one is just a straight translation, okay? We have, I'm going to use for my variables this. I'm going to say that B represents Bob and A represents Alice, okay? So when we do a straight translation here, we see that B is Bob, is a math symbol that means equals. And then when we say 2 years older than his sister Alice, okay? So if I don't know what Alice's age is, we'll just call it A. And when we say 2 years older than this, that means we're going to take whatever Alice's age is and we're going to add 2 to it. So Bob is Alice's age plus 2. The second equation says together the sum of their ages is 8. So that looks like this. A, which is Alice, and B, which is Bob, together add up to 8. So if we set up these two equations here and put them into our t-chart, we have B is equal to A plus 2 and A plus B is equal to 8. I'm going to go ahead and use the substitution method because B is already by itself in this problem. So if I know what B is, I could take it and substitute it in for this B that's right here. And so we'll have A plus 2 is equal to 8. We end up with 2A plus 2 is equal to 8. 2A is equal to 6, and we get that A is equal to 3. And again, once we know what our A is, we go back over to the other side, we plug it in there, and we're going to get B is equal to 3 plus 2, which is 5. Okay? So what does that mean? That tells us that Alice's age is 3 and Bob is equal to 5. Okay? Now, for our last age problem here, let's talk about this. This one is a bit of a doozy, okay? And I would go ahead and maybe put a star by this, but this one says there's a hint, and it says that when one equation represents the present and the next equation represents the future, you must add the number of years ahead to all parts. So for example, let's just say that we have two people, okay? If this person gets 5 years older, well then this person also has to get 5 years older. So both parties are going to age by 5 years together. Let's talk about what that looks like in a second here, okay? In the year 2000, Ed, I'm going to go ahead and call E. In the year 2000, Ted, I'm going to go ahead and call T. So for the first equation, it says in January of the year 2000, Ed was, and remember was is the same as is, but that's like the past tense. Ed was one more than 11 times as old as his son Ted. Okay? Well, his son Ted is unknown. 11 times this is 11 times T. Oh my gosh. Hang on. 11 times T. And then when we say one more than this, what we're going to do is we're going to add 1. So Ed is 11 times T plus 1. Okay? Now, for the next equation here, it says in January of 2009, Ed was 7 more than 3 times as old as Ted. How many years has taken place since the year 2000? Well, in the year 2000 to the year 2009, this is 9 years has taken place, right? So what this tells us is that both Ted and Ed have gotten older by 9 years. So what does this look like? Well, if we take a look at this first part here, Ed has gotten older by 9 years. Ted has gotten older by 9 years as well. But the problem says that Ed was 7 more than 3 times as old as Ted. So Ed, which is right here, is 3 times as old as Ted plus 7 more. So there's the breakdown of that equation. Okay? So if we go through and take this one and simplify it out, here's what we end up with. We have E plus 9. If I distribute the 3, we have 3t plus 27. And combine these, we end up with E is equal to 3t plus 25. Now, I want to use the substitution method here because if I have an E right here and I've got an E right here, I'm just going to go ahead and replace E with 3t plus 25. Okay, these are the two equations. Just set them equal to each other. Once I know that they're equal to each other, I can solve for t. We get 8t is equal to 24, which means that t is equal to 3. And again, once we know what t is equal to, you can plug it into any equation you want. So I know t, if I was to plug it in here, that would be a terrible idea because I would have to try to work through that, right? But I could take this t and plug it in right here and solve for e, or I could take it and plug it in here and solve for e. I'm going to go ahead and plug it into the top, which means we're going to have 11 times 3 plus 1, which means that e is 34. So that means that Ed is 34 years old and Ted is 3 years old. Okay? All right, next question. A couple of numbers and combinations of this. Okay, so this is a very common one that you see on the ACT. Let's navigate this one. It says that the sum of two numbers is 28. So let's assign the variables that x is the first. And what I'm going to do is I'm going to say that y is the second. And I'm going to intentionally make it a larger value. Okay, it's because we have a larger value here. I don't know what x or y are, but I'm going to go ahead and make y just be the larger number. Okay. Okay, so let's set up a couple equations. It says the sum of the sum of the two numbers is 48. So that just means we're going to add them together. So x plus y is going to equal 48. For the second equation, it says the larger number, so that's y, is 3 more than twice the smaller. Well, twice the smaller is 2x. 3 more than this is plus 3. And there's your second equation. Y is equal to 2x plus 3. I'm going to go ahead and use the substitution method. Since I know what y is equal to, I'm going to take it and plug it in for y right here. That means we have x plus 2x plus 3. We'll go ahead and simplify. We have 3x equals 45, which means that x is equal to 15. Once we know what that is, we'll plug that back in over here for this x, which means we have 2 times 15 plus 3. So that means we have y is equal to 33. So what do these mean? That means the first number is 15 and my second number is 33. Okay. Let's switch over to money problems, so coin problems. It's important to recognize with money that you have two different things going on whenever we talk about money. Like if I was to say, I have 3 dimes. Well, I gave you two numbers there. I said 3 and then a dime. How much money is a dime worth? Well, a dime is 10 cents. So if I have 3 dimes, I have 30 cents. I've got how many I've got, and then I've got how much money I've got. And that's exactly what's going to happen here. Says that your uncle has been collecting gold tone $1 coins. The 26 coins in his pockets are all dollars and quarters, and they add up to $17. So you can see we have two different equations here. We've got one that talks about how many coins we have, and then we have one that talks about how much money we have. So let's set up the unknowns. Quarters are going to be Q, and dollars are going to be D. It's just what I chose. And let's go with the first expression, the blue one. It says that 26 coins in his pocket are all dollars and quarters. So that's the quantity equation. That's how many we have. Well, the dollars and quarters together, we have 26 of these, right? So I have Q, quarters. I have D, dimes. There's a total of 26. I'm sorry, dollars, not dimes. Okay? Now let's talk about how much money we have. Each quarter is worth 25 cents. Each dollar is worth $1. So the value that we have here is that it's 25 cents for every quarter, and it's $1 for every dollar, and those together add up to 17. Now I'm going to go ahead and use the substitution method here because I can see clearly we have a couple of variables that could be easily solved for to get them by itself. If I got D by itself, we're going to take the Q and move it over here. We have D is equal to 26 minus Q. Once I know what my D is, I can go ahead and substitute it in for D over here. And we have 0.25 Q is equal to 26 minus Q. Combine our like terms, divide by negative 0.7, we get that Q is equal to 12. So there are 12 quarters taking place. Now if we go back and plug that into the other side, we do D is equal to 26 minus 12, and that tells us there are $14. So put these together, there are 12 quarters, and there's $14. Okay? And again, we could check this. This is $14 right here. And 12 quarters, remember that 4 quarters is $1, so this is $3 more. So we have $17 here, and when we add these together, there are 26 coins. Okay? All right, I'm going to show you guys how to do a little chart here for a problem. Okay, whoops. And so these are investment and interest problems. Okay, and these are actually just like money, but I'm going to show you a different way to kind of set it up just to keep organize your thoughts. Okay, so Jim's going to go ahead and invest part of his $20,000 at 12% and the rest at 14%. The total income from these investments is $2,560. How much did Jim invest at each rate? So here are the unknowns. We have X is going to be first investment, like how much money he puts in that first investment. Y is going to represent the amount that he puts into the second investment. And then we're going to have the total down here about what's being put in. Now let's talk first about quantities, okay? Just the amount that's invested. I don't know how much Jim put into the first one. I have literally no idea how much he put in. I don't know how much he put in the second one. But I know that he put in a total of $20,000. So X represents the amount that he put in the first one. Y represents the amount that he put into the second investment. And we know that there's a total of $20,000. So if we put all these together, he has x plus y. He put in a total of $20,000, okay? For our second equation here, we have the interest that's actually getting earned. Now, on his first investment, he's going to be earning 12% interest for all the money that he put in. So what that means is he's going to be earning 0.12x. So if you put $100 in, he's going to earn 12% of that. He's going to earn 0.12 times 100. If you put $1,000 in, he's going to earn 0.12 times 1,000. The same holds true for the rest of the money. The rest is going to be put in at 14%. Okay. Now, for the second part of our second equation here, we have to figure out what's the total amount. Well, it says right here that the total income that he's going to earn, the total interest, is $2,560. So let's put these together. 0.12x, 0.14y, combine these, we're going to end up with 0.12x and 0.14y for a total of 2560. So put these two equations together on our t-chart. Why am I using a t-chart? Well, I have two variables here that I could easily get by themselves. So I'm going to do that. I'm going to use the substitution method. If I get y by itself here by moving x over, once I know what y is, I can go ahead and plug it in for the y over here in this other equation. Okay. Replace that y with 20,000 minus x. Go ahead and work through solving this. We're going to distribute first right here. And then we're going to go ahead and combine our like terms. And then we're going to go ahead and move the 2,800 over. Divide by negative 0.02, and we get that x is equal to 12,000. Once we know what x is equal to, we plug that into the other equation here for this x. And so we end up with 12,000 or 20,000 minus 12,000, so there are $8,000 being invested there. So what does this really mean? Well, he invested $20,000. We can see that these add up to $20,000. If I took 12,000 and put it in for x right here, that's going to give us the amount of money that he's going to earn on the first one. If I put 8,000 into here, that'll tell us the amount of money earns at 14%. And if I add these together, that's going to add up to $2,560 for the total interest. So it's $12,000 at 12% and $8,000 at 14%. Okay. The next question, I apologize, on my notes here, I've got a bum question. This question is not possible for you guys to do at this point. It's not a linear function. It's actually supposed to be an exponential function, and that would look like this, that a is equal to 600 times 1.06, and not 1.06, 1.04 raised to the t power. But that was an accident putting this on here. It doesn't belong here, so let's just move on. Okay. Number 9, and we have two more here. Mr. Scott needs 240 milliliters of 30% alcohol solution. Unfortunately, he can only find a 20% solution and a 50% solution. How much should he mix of each to get the solution he needs? So this is a classic mixture problem. When we're talking about mixtures, think of it like milk. If I have whole milk and I have skim milk, I have one that has fat and I have one that doesn't have fat. I can put these together and I can get a 2%, I can get a 1%, but how much should I use of each in order to get those correct percentages? Well, that's what's happening here, okay? He has 240 milliliters, okay? Now we have two things that we're going to go ahead and mix, okay? When we look at this mixture, I don't know how much of this mixture we're going to use. No idea. Doesn't say anywhere how much. It just tells us that we have some mixture here. It's a 20% solution. And so what we're going to say is that it's 0.20x. Okay. I have some second thing. I don't know how much we have of it. So that means that we're going to have some y amount of some 50% solution. Now we have two equations that are taking place here, right? We have how much we're going to have of it, and then we have the percentage of the solution. So just looking at how much we have of each, we have, we have a total of 240 milliliters. So there's x and y. We're going to take these and pour them together, and we're going to end up with 240 milliliters. So that's our first equation, that x plus y equals 240. The second equation is talking about the percentages. It's 0.20x and 0.50y. We're going to end up with a 30% solution, and it's going to be 30% of the amount that we had there, which is 240 milliliters. So let's add these together. We're going to get 0.20x, 0.50y, and that's going to equal 72. So now from here, choose your method, substitution, elimination. I think you guys have the hang of it at this point. So these are the two solutions that we should get for this though, pun intended. We have 160 milliliters of the first one at 20%, and we have 80 milliliters of the second one at 50%. Okay. Last question we're going to deal with here. The cafeteria wants to sell 10-ounce trail mix packs. They can buy chocolate chips for 30 cents per ounce and almonds for 80 cents per ounce. How many ounces of each should they use to sell the mix to sell the packs for $6.25? So my two unknowns here are X is going to be chocolate chips and Y is going to go ahead and be our almonds. I don't know how much we have of each, but here's what I know. I know that there's X chips and there's Y almonds. There are going to be a total of 10 ounces in this problem. So X plus Y is going to equal 10. Okay. The amounts that we have for cost, we have 30 cents for each ounce and 80 cents for each ounce. But here's what we know. We have a total of $6.25. So for this one, I intentionally went ahead and chose the elimination method because I haven't really done many of them. So again, what I did was I just need to get some opposites in here. And these two right here, those could be opposite each other if I just get a negative 0.8 at the top here. So what I did was I took this 0.8 that's right here and I multiplied the top by the same number, but I used a negative so I can get opposite signs. If I distribute this out, I have negative 0.8x and negative 0.8y equals negative 8. For the bottom, we never changed it. It stays exactly the same. If I go ahead and combine these values together, we get negative 0.5x, we get a 0, and then we add these together, we get negative 1.75. Okay. Divide by negative 0.5, we get x equals 3.5. And again, once we know what x is equal to, we can take that and substitute it in. I'm going to put it into this equation right here. That means that we're going to have 3.5 plus y is equal to 10. Subtract 3.5, we get 6.5. And that means ultimately that we have 3.5 ounces of chocolate chips and 6.5 ounces of almonds. That is it. So you guys can kind of see as you're working through these, and I know I went through them kind of quickly, so go back and watch them at your discretion. But the idea here is that you see kind of similar setups for every one of these, and then similar ways of actually going about solving these, okay? But that's it. Hopefully you guys don't have any questions, but if you do, feel free to seek me out for some help. Until next time, Mustangs, you guys take care of each other. Be safe, be responsible, be respectful. Don't forget to like and subscribe to my channel, and you have a wonderful